Do you need me? All right, I want to go over this really quick. I have the rubric attached, but I just want to kind of talk you through it before I just show you all the answers. So again, looking at this picture right away, I see that it's geometric shapes. And so it says let f be continuous on the closed interval from -3 to 4 with f of 0 equals 3. The graph of f prime, the derivative of f, consists of one line segment, a semicircle. So this is f prime. So it says where is f increasing, right? So this is just a throwback. We've talked about this a lot. F is increasing when f prime is positive. So where would that be? That would be from -3 to -2 only, right? Because it's above the x-axis. So what does it say? It says the function of f is increasing from -3 to -2 since f prime is greater than 0. One for the interval, one for the reason. And you could have used parentheses, I promise, on that, not brackets, like I did. Part B says find the x-coordinate of each point of inflection on the graph. Justify your answer. So what do we know about points of inflection? On the derivative graph, points of inflection show up as max or mins, right? So I'm going to say points of inflection. That's not a good one. Inflection points show up as relative max or mins on f prime, or I could say inflection points are where f prime changes from positive to negative or negative to positive. This is the graph of the derivative though, so sometimes it's weird because you feel like it's a sharp corner and it shouldn't work. But at x equals -2, so at x equals -2, f prime changes from decreasing to increasing, and also at x equals 2, because f prime of x changes from increasing to decreasing. Or I could have talked about a relative max or relative min. So let's see what this says. And so it says x equals 0 and x equals 2 only. Oh, I totally screwed that up, didn't I? And my reasonings. Gosh, look what I did. I gave you the y value here instead of the x value. I would not have got my point for that. But it's x equals 0 and x equals 2. Look at part C. It says find the equation for the line tangent to the point at 0, 3. So what do we need to find a point of tangents or a line of tangency? We have a point already, and we also need to find f prime of 0. And what is f prime of 0? This is the graph of f prime, so that's what I did last time, right? It's -2. So my tangent line is y minus 3 equals -2 times x minus 0. And you don't even have to simplify that, right? Look at this. And they simplified it, but I promise you don't have to. And that was just 1 point, all or nothing. So if you messed up your slope, you don't get any point on that. So why did they give this question? 1, it's always good to review. But 2, look at part D. It says find f of -3 and f of 4. And this is where they gave us this point here, okay? And so this is like what we did on the homework yesterday. So if I'm going to do f of -3, I have to use this point that they gave me. So I have to use the fact that they gave me f of 0 equals 3. So I'm going to use 0 to -3 of f prime of x equals capital F, or since they use little f, f of, oh, let's think about how we want to do this here. Okay, there's a couple ways to do it, but we got to keep track of our negatives. The first thing that I notice is this is in the wrong order. So I'm going to change this from -3 to 0. If you don't change it, I think the negatives just work out over here nicely. She has the book, I think. Or no, did you bring it back? They're all right here. And so this would be f of 0 minus f of -3. And then this is my -3 to 0 up here. So -3 to 0, I need to find the area of these. This one's below the x-axis, so I'm going to kind of write up here and then I'll scroll back down. Oh, that's no good. So this one is 1/2 times 1 times 1. And then this one is 1/2 times 2 times -2, right? So that's going to be 1/2 minus 2. 1/2 minus 2. But I have a negative out there, right? 1/2 minus 2. And then I know f of 0 they gave me. F of 0 equals 3. And so I'm going to subtract 3 over and get -3 minus 1/2 plus 2 equals negative f of -3. So what would that be? -1 minus 1/2 is -3/2. But I still have this crazy negative hanging around. So I think that I get f of -3 equals +3/2. I wonder if that's right. I should have checked that first. Oh no, look, they have that it's 9/2. So where did I mess up my negatives here is my question. Because if I would have made this a 3, I don't know. I always mess up my negatives. So let's see what they did. This is what I had. So they kind of did it separately than I did. They didn't flip their negative around so much. So they got -3/2 here. And that's my area. 1/2 minus 2 is -3/2. And then they just did f of 0 plus that because of the negative. Gosh. All right, I'm sure you don't care about my mistake. As long as you understand it, I care about my mistake. -3/2. Maybe I just made a stupid mistake. Okay. So this would be negative of -3/2. I agree with that. But my issue is, oh, I'm an idiot. I subtracted in the wrong order, kids. Hopefully you caught that. It's supposed to be f of b minus f of a. So it should have been f of -3 minus f of 0. So that was just a silly mistake by me, because then that would have been -3. So then I'm going to add 3 over, and that's going to become 3 plus 3/2, which is 9/2. Sorry. I had it right, and I just mixed up those things. Okay, do you even want me to do f of 4 now? F of 4 isn't as tricky because if we start with 0, I'm going to write it up here, okay? It's going to be the integral from 0 to 4 of f prime of x dx equals f of 4 minus f of 0. So there's no crazy negative in there to flip around. But when I go from 0 to 4, that's a little tricky because the area is this area in between here. And so it's almost like we have to take the area of this whole rectangle and then subtract out the area of the semicircle. But also it's below the x-axis, so it should be a negative number. That's kind of weird, right? So the area of the rectangle would be, to what I read this, would be like 4 times -2. But I need to subtract out the area of the semicircle, which would be 1/2 pi times 2 squared. So that would be -8 minus 4, nope, 4 over 2 would be 2 pi. But I wonder, because it's below the x-axis, is that correct? Should this have been a negative? So because it's below the x-axis, it also should have been a negative? This is the one that I always get crazy on. All right, let's look at this one. So they just put the negative out front, knowing that the whole thing's negative. So I guess that's probably a good idea. So you really get -8 plus 2 pi, and then you add over your f of 0 and get negative 5 plus 2i. Notice the points for this, okay? You got a point for doing the triangles and a point for the area of the rectangle minus the semicircle, and then you got a point for using the fundamental theorem of calculus on each one of those. I was trying to make it make more sense, but maybe I just screwed it up, all right? All right, let's look at this one. This one is similar to one that we did already back before the last unit, and it talks about velocity, and then they're asking questions about acceleration. And so, again, they give you a chart and they give you a graph. So it says, during what intervals of time is the acceleration of the car positive? Give a reason. So acceleration is the derivative of velocity. So acceleration is going to be positive when this is increasing. So acceleration is positive from 0 to 35 and 45 to 50 because velocity is increasing. Notice you got a point for each interval and a point for your reason. Notice it says ignore inclusion of endpoint, so you could use parentheses or brackets. Find the average acceleration. Average acceleration is just our slope, right, from 0 to 50. So average acceleration, you can use the chart to get those answers. If this was a calculator question, you could work it out, but your quiz is not calculator, so you could leave it not worked out. Find one approximation for the acceleration of the car at time equals 40. So one approximation means you're going to do the average acceleration. I would have probably used 35 and 45 the same way that I did part B. Notice that they did, oh my gosh, they did so many different things. This is probably what I would have done, the average velocity, average acceleration function. And it says, or you could use the slope of the tangent line between those 2 points to get that. All right, so 1 point for the method showing your work and 1 point for the answer. And then part D, this is our new thing that we've learned, Riemann sum or RAM, using the midpoints of 5 subintervals of equal length, and they're telling you to go from 0 to 50. So if they tell you to do that, you should be able to break that up. You could draw the picture if you want. 0 to 50, if we want 5 equal ones, wouldn't that be like 0 to 10, and then 10 to 20, 20 to 30, 30 to 40, and 40 to 50? And we're using the midpoints, and so like this would be my midpoint. The midpoint of this one would be like here, and the midpoint of here, midpoint, midpoint, right? And we can get all those values from here. You're going to get points for setting this up. Without a calculator, you don't have to work it all out, but we're approximating the value here, and so you can leave your answer like this without a calculator. And what does that represent? We kind of aren't to that part yet, but since it's velocity, if we're going backwards, we get position, so that represents the total distance traveled from 0 to 50 seconds, okay? And then the last one here, again, another table, and it's just part A and B here, but it says the rate at which water flows out of a pipe in gallons per hour is given by a differentiable function r of time. Use a midpoint Riemann sum with 4 subdivisions of equal length to approximate 0 to 24, and using correct units, explain what's happening. So again, going backwards, if this represents the gallons per hour, right away I can tell you going backwards it's going to be gallons. And midpoint with 4 subintervals. If we're using the midpoint, we're going to go from 0 to 6, from 6 to 12, from 12 to 18, and 18 to 24. And so, again, without a calculator, you could leave your answer just like this. Because they're equal length, that's why you could factor the 6 out front. And again, if it's gallons per hour, if we're going backwards, this represents the total number of gallons in that first 24 hours. And notice, you get a point for just knowing what numbers to put, a point for your answer, and a point for your explanation. And then part B says, is there a time where the derivative equals 0? So there's lots of ways, multiple ways you could do this, but this makes me think of Rolle's theorem. And so when I look at this and I see, are there any numbers that equal the same? At 0 and 24, they both equal 9.6. But I don't know that I'm allowed to use the endpoints, I wonder. Let's see what they say. 10.4, none of those other ones repeat themselves though, right? Yeah, so they say since R of 0 and R of 24 both equal 9.6, the mean value theorem or Rolle's theorem represents that. So mean value theorem or equivalence, that's going to be true, that the derivative is going to be true. to equal 0. Okay? So tomorrow we're going to have a quiz. Look over your stuff. Look over these for your response. I guarantee you're going to have to do a Riemann sum or a trapezoid sum, and you're going to have to do the fundamental theorem of calculus.